All right, so I'm going to talk about infrastructure as code, specifically using Terraform today. You guys probably heard infrastructure as code thrown around either in your personal research or at the DevOps training last week. So we're going to talk about kind of what that is and the principles behind it. So feel free to grab food, guys. Don't rush in. So what we're going to talk about today is kind of a brief outline. First, we're just going to talk about kind of what the definition of infrastructure as code is, kind of the textbook definition, and then we're going to talk about why it's important and what problem does it solve, because as many of us know, with all these lovely tech things, they don't actually sometimes solve any problems, and it's just kind of buzzwordy and feels good to do. So we're going to talk about why it's important and what it solves, and then we're going to kind of glaze over the different providers and different implementations of infrastructure as code. And then we're going to specifically dive into why I picked Terraform for this and kind of examples using Terraform. And then at the end, we're going to go through a full end-to-end demo building some infrastructure for a website that I run. And actually that reminds me, it takes a very long time to run. Well, not a very long time, but I'm going to start that right now before we get too into it. Sorry about that. Anyways, so what is infrastructure as code? So this is basically the principle that we want to manage our physical infrastructure like databases, network servers, firewalls, all that sort of fun stuff in a descriptive model similar to how we would want to manage our application code. And so kind of, why do we care about this? So why is it important? What are we doing? So infrastructure as code, this solves the problem that we've all seen and all know of configuration drift. So this is basically a fancy way of saying that over time, our environments start to slowly differentiate from one another. We have dev, we have DevCS, DevQA, training lab, prod. These are all unique environments in this day and age. Not one of them is the same. We all talk about how, I think we were talking about it yesterday in the meeting, how stuff will work up through training lab, and then when we get to prod, something's a little bit different because deployment breaks. So that's what we're seeing here, is that these environmental differences, deployments become problematic, and then maintenance on these environments is manual, and changes are difficult to document and track. So kind of with the conceptual difference that we want to start thinking about with infrastructure as code is this mentality of pets versus cattle, is what a lot of people call it. So kind of what we have now is like the pet mentality, where these servers are indispensable. They're very unique. We manually care for them. They're our pets.
We love our servers.
What's that?
We love our servers.
Yes, we love them. We don't want them to die. And so moving into more of a DevOps or infrastructure as code mindset, we have this idea of cattle, where our servers are not unique. They're meant to be killed. They're meant to be replaced, using automated tools. And so we don't care if they die. We can bring them back up easily with the tool. Right. So another idea of why this is important is that infrastructure as code provides idempotence. So we all know what that term means. If we're thinking about HTTP REST APIs or something, your HTTP GET requests should be idempotent. So this is just the principle that a process can be ran multiple times and you're going to get the same result. So an HTTP GET request, you can hit the endpoint multiple times. It shouldn't modify your data at all, and if it does, then it's not idempotent. But same thing with infrastructure as code, is that each deployment command can be repeated multiple times, and you're going to end up with the same infrastructure as a result. So another benefit that we're going to see aside from idempotence is now infrastructure gets the same benefits of source control as our application code does. So this means we can version our infrastructure, meaning that if we have version 1, then we know everything's good. If we want to roll out some changes, some configuration updates to version 2, then that breaks everything. We can easily roll back to version 1, recreate the infrastructure as it was, where everything's working, and go back and work on version 2 again. Another thing we can have is pull requests and code reviews for our infrastructure. So, instead of, maybe creating a change management ticket or something like that, where some of the detail gets lost in translation or lost between teams, each individual person could now actually create a change to the infrastructure, make a pull request, and then that could be reviewed and approved by, whatever authority there may be. Then your code change would make it into the master branch and then pushed out into the next deployment of the infrastructure. Is there any questions kind of on so far of what infrastructure as code is trying to do, or why we care about it?
Why do you need a DR policy if you have infrastructure as code?
You need a DR policy?
Yeah, just start up the org again, or the environment again.
I guess your DR policy then would more pertain to like your actual data, as opposed to the actual configuration of your infrastructure.
Yeah.
So here are probably the 6 most popular implementations of infrastructure as code. This is what's going to show up if you Google infrastructure as code. This is by no means like an exhaustive or prescriptive list of things, meaning that there are others out there, or your implementation of infrastructure as code can take a different path. So, things like you can use ARM templates if you really want to. I don't particularly like ARM templates, but they're available. And then even something as simple as like a library of Bash or Azure CLI scripts can be your infrastructure as code, just as long as you have a consistent way to bring up your infrastructure in a repeatable manner. You can be doing infrastructure as code. And so I highlighted this one, AWS CloudFormation, because that one is proprietary to Amazon. So we don't really care about that one. It only works with AWS, but it's out there, so we just kind of know about it. And then I think, Bill, you had mentioned Chef was being used by, was it Mid-America? Yeah. So that's another tool that is obviously working for them pretty well. So, with all of these, kind of thing I want to talk about is why I picked Terraform kind of for this project. And so there's 2 main attributes as to why I wanted to use Terraform, and then there's a couple other ones that just kind of followed along. So we're going to first talk about the difference between a provisioning tool and a configuration management tool. So the tools like Chef, Puppet, Ansible, and SaltStack on the previous slide, those are all configuration management tools. So that means they're a tool that's going to be running, that's designed to manage and install software on existing servers. So this would be like pushing updates and different software to VMs, stuff like that. Whereas Terraform and CloudFormation, these are provisioning tools. So these are designed more to actually provision the servers or the resources themselves. And so for this project, I was using a combination of both Azure and AWS. So I had really no physical servers to manage or update. I was just provisioning cloud resources. And so Terraform just made more sense in that capacity. It was just a better tool for the job. And I guess I should kind of clarify that a provisioning tool and a configuration management tool, like these attributes aren't necessarily mutually exclusive. So a provisioning tool can do some degree of configuration management, and a configuration management tool can do some degree of provisioning, but it's more just some tools are designed to do things better than others. And so, Terraform I thought was better suited to my task.
So, Andy, just to kind of dive into that just a second. So Terraform we would use to say, okay, I want to build an app server, a database server, and then provision it, based on the specs that we've defined.
Mhm.
But then something like Chef or Puppet to actually configure IAS and the app pools and all that stuff. Is that kind of where you're going with that?
So, no, so I guess for a provisioning tool, it's more gonna be like, so in my examples, like I use Terraform to create like an Azure app service. So there's really no configuration beyond creating the app service in Azure.
Right.
So for like Chef or Puppet, it would be more of like, if you had like a VM in Azure, like the one you guys just stood up, if you wanted to like push out updates to a host of VMs, you could do that through Chef or Puppet or something like that. And so, like you said though, you can do like a hybrid approach where like if you wanted to use Terraform to provision all the VMs and then use Chef or Ansible and Puppet to manage the configuration of those, like you can very well do that as well. I think a lot of places do that have to manage VMs and actual business servers like that.
Yeah, and I guess maybe I'm just jumping ahead a little bit, but that's kind of how I would see some type of a tool, because we'd want, like, if a developer wanted to spin up an app pool, well, we would have all that pre-configured as far as .NET versioning, app pool breakouts, users assigned to those app pools, like,
Yeah,
all that stuff, we'd want all that automated from top to bottom. And
yeah. So that could all be done through a configuration management tool, and then you could provision just the pieces that you need.
Yeah.
Cool.
Yeah.
So are these tools things that are intended to be used or could be used like in Azure DevOps?
Yes. So my final example. All right. Tackles that. No, that's fine. That's fine. So the next kind of attribute that I was looking at was the actual language that these different tools use. And so we're going to look at the difference between the declarative versus the procedural language. And so Terraform and I believe Puppet and CloudFormation use a declarative style language, while the others use a procedural style. And so a declarative style means you just write your configuration for your desired end state. And then the tool is going to, that's why the tool is built, so that it can figure out how to get from where your state is currently to the desired end state that you want. Whereas with a procedural tool, you have to write actual step-by-step instructions as to, okay, I am in state X, I want to get to state Y, so how do I do that? And so I will show you kind of a very brief comparison between the two. So I'm going to do a disclaimer here in that these two steps, these two Ansible steps, I didn't learn a whole lot about Ansible. I just kind of ripped these out as some examples. So I don't know if these are actual like 100% runnable steps, but I think it demonstrates the idea good enough. Can everybody see that okay?
Yep.
Okay. So this is an Ansible, what they call a playbook. It's basically just it's a configuration script to, in this case, create an Azure App Service plan. And so we just set some properties that it needs to do, and we're going to say it's going to be on the standard 1 tier with 1 worker for this Azure App Service plan. So if we look at the same thing in Terraform, you can see it looks very similar. So we're creating an Azure App Service plan. We're assigning it basically the same attributes, and it's going to be on the standard tier with a capacity of 1. And so for the initial provisioning, this, a procedural tool and a declarative tool might not look that different, but as your infrastructure grows and you want to scale things out or change things is kind of when the difference comes in. So in this Ansible step 2, this is kind of where we want to, we're getting a lot of traffic. We need to scale up our app service plan. So the first part of this step 2 is we have to, I guess, register these facts of what our state currently is, and then make the change based on what we want. So if we want to update to standard tier 2 with 3 workers, we get our existing infrastructure, and then we scale it up to what we want. Whereas in Terraform, you wouldn't need to add an extra step. You would just come in here, you would change this to standard 2, and this to your desired end state, workers of 3, and then you would rerun your Terraform command with the same file, and it would figure out the changes it needs to make. And so the big benefit of that is that as your infrastructure grows, of course, so as your infrastructure grows and becomes more complex, so does your procedural code. And so you kind of have to know your starting state to where you want to get to, as opposed to just declaring your end state. So the order starts to matter. And with a declarative language, you always know the end state. So the code always represents your current infrastructure state. Whereas with the procedural style, you have to know the order in which those scripts were executed. Because if you executed them in a different order, you would end up with a different end state.
Would another example of procedural just be like a series of PowerShell scripts or PowerShell statements that provision all that stuff?
Yeah.
There are a lot of examples of that and mapping that to what a procedure
Yeah, so
would look like.
like that would be like if you had a library of Azure CLI scripts or something like that, would be another procedural style. So then there's some other attributes that some people may take into account. After the first two, my mind was kind of made up for this project, but just some other ones are like mutable versus immutable infrastructure, agent versus agentless, the size of the community, and then the maturity of the tool. So here is just kind of a breakdown of all the tools that we listed and their various properties. So the main thing I was looking at was a provisioning tool with a declarative language, and since CloudFormation only works on AWS, Terraform was kind of the pick for me. So any questions on the different kind of types of providers or kind of differences between them before I dive into more Terraform specific stuff? Okay. So this is going to be our core workflow with Terraform. So it's pretty simple. The first thing you do, the init, that just initializes your environment to actually run Terraform commands. It has to download a few files to be able to execute the commands. And then the next command is plan. So this is our dry run where you have your configuration file, you run a Terraform plan. It's going to print out everything that it's going to do, and you can look at it, review it without fear of actually changing any infrastructure. The next thing we're going to do after we plan, we made sure everything looks good, is we're going to do the apply. So apply is kind of your live run. It's going to print out your whole plan again, and then it's going to prompt you to say, is this what you really want to do? So Terraform doesn't know if what you're doing is good or bad. It doesn't know that, hey, deleting this database is a bad thing. It leaves it up to you, the user, to review the plan and make sure it's doing what you want it to do. So after it prompts you to say, yes, that's what I want to do, it'll go through and provision the infrastructure, do the things it said it was going to do in the plan. So then you'll kind of keep doing that workflow as you need to make infrastructure updates. And then if you, for whatever reason, need to tear down your whole infrastructure, you'd run Terraform destroy. So that's basically everything in your configuration file that you have there, it will delete. Your infrastructure will be gone. You can start from a clean slate. You can also do targeted destruction. So if you only want to destroy one thing, you can say Terraform destroy and then point it at a particular resource. However, I don't think they recommend you do that a whole lot because it can kind of monkey with the state of Terraform and you can kind of get into a bad state. But it's there if you really need to use it. So I've got 3 examples. One is just going to be a really simple, basic one. And we're going to kind of build on that in example 2. And then 3 is the end-to-end example with Azure DevOps that I had started earlier. We'll take a look at that. So let's jump into our first example here. So a few things about this file. So this is a basic Terraform configuration file, suffix .tf. Terraform uses a language called HashiCorp configuration language. And it's kind of a mixture between YAML and JSON. As you can see, they have curly braces and strings and stuff like that. So it's a proprietary language to the company that makes Terraform, but it's pretty easy to pick up because it looks very similar to JSON. And so starting at the top, this is just our basic, declaration of Terraform. We're configuring it to use, version 0.12. Then as we move down this provider block here, this is where we start to set up our cloud-specific things. So Terraform has a very long list of cloud providers that it supports, Azure being one of them, on top of, AWS, Google Cloud Platform, DigitalOcean. They've got like 50 of them. So, they have support for a lot of the different, or probably almost all of the different cloud providers.
I have a question about the greater than or equal symbol.
Yes.
Is that an actual alt code that you typed in that it expects,
No, that's just
or is
my-
that just
That's
a,
my font.
okay.
I think it's like Hero code or something.
So when you typed that in, you actually hit greater than equals as
Yeah.
opposed to, okay.
And so it's like I think it's like
Font
Cascadia
features.
code, or it's like the font features. Yeah. So anyway, so down here, this is where we're actually declaring our resource that we want to create. And so we're going to create an Azure resource group. And then this part right here, this is kind of like a Terraform object variable. And so later on, we'll kind of see that we can use that in different spots. But for right now, it's not really doing anything. So we're just going to assign it a name, Terraform Lunch and Learn, and it's going to be in the East US data center.
Is that saying where our tenant is, or is that where Terraform?
This is like where my tenant is, or where,
Can that be a global, can that be defined in like a global library somewhere in case we move locations?
yeah.
Okay.
Yep. So we're gonna pull up our PowerShell here. Is that big enough? Can you guys see that?
It's a little
A
small.
little small. How do you scale PowerShell? Yeah.
We can turn around maybe. It's still a little small, but.
Go to edit.
Edit.
Front row.
Oh, wait, no, property, sorry.
Size.
Properties.
Old man font.
Is that better?
There we go.
All right. Cool. So one thing that I had already done prior to this was I had to log into the Azure CLI so that Terraform knows how to authenticate with my Azure account. So I just did a AZ login, and then it caches the credentials in this current shell. So the first thing we're going to do is we're going to do our Terraform init. As you can see, it initializes the backend, initializes the providers, so our Azure provider, and then it says, woohoo, successfully initialized.
So did you install the Terraform modular in PowerShell then? Did I miss
No,
that
so
piece?
Terraform it's just a single executable that I put on a path variable.
Oh, okay, gotcha.
Yeah.
Perfect.
Okay, so our next thing we're going to do is we're going to do our Terraform. Terraform plan. Now it's kind of figuring out what it needs to do. Oh no.
I know. We all. You should be able to do tab commands to finish it.
That's what I was getting at earlier. All right, you're not.
You have to sacrifice to the demo gods. I tested this earlier. What?
I did. I know it works.
Wasn't it Bill Gates who had a blue screen of death when he demoed like Windows 95 or something like that back in the day? You're a little bit far from that.
Could be worse, you'd be throwing steel balls at a new car.
Yeah, a little too hard.
Too soon? It's gonna go through.
There we go.
There we are. One thing we've learned as we're waiting for this, anything in Azure, it just takes time. You just have to be patient. Even if you do a system-wide change, it could take hours for stuff to take effect. And
So-
another thing while we're waiting too, just a reminder, everybody that has MSDN accounts, you have $150 a month you can use in Azure credits. So feel free to experiment. Like that money is part of the subscription, so please feel free to experiment.
All right, so now that we got rid of the technical difficulties, we can see that our Terraform plan is showing us exactly what it's going to do. It's going to create an Azure resource group. It's going to have this name called Terraform Lunch and Learn, and it's going to go ahead and create that. So next we do our apply. Really slow.
And so if I'm thinking what an Azure Resource Group is, if it's the same as what I'm thinking, Andy, so an Azure Resource Group is just merely a boundary to go around your assets that you're gonna have up in Azure. It's the foundation for building infrastructure in Azure.
Yeah, so it's a very as you can see, there's 4 attributes on it. It's a very simple
Yeah.
resource, and it's meant to group things together to keep things,
Yeah, so for example, we'd have, one for prod, and then it'd be a prod resource group, and then maybe one inside of that would be like a centric resource group or something.
Yep.
It's just that we can scope within that boundary.
So here it's prompting us, are you sure you want to perform these actions? And so we say yes. Now it's going to go ahead and Terraform is going to interact with the Azure CLI using its provider, and it's going to create the resources for us. As you can see, it's creating, creation complete after 1 second. And so now we can check to see that it actually did what it's going to say it's going to do. So we could either pull it up in the portal, like civilian, or as us developers, we could use the Azure CLI. We can see we now have a resource group called Terraform Lunch and Learn. So then, as I said before, let's say we don't want this resource group anymore. Destroy. Wait for it to.
I'm a little disappointed in you though, Andy. As developers, we don't use the command line. We take our commands, we stick them into a script and then run the script.
From the Azure boys.
Go. Yeah. So, are you sure you really want to do this? You do. Now we can see it's destroying. It should be destroyed after a few seconds. Still destroying. You should see the final example. I tested it last night on Azure DevOps, and it took like 30 minutes to run. So it just says like every 10 seconds, still working.
Yeah, so another bit of insight, so Dev Azure is obviously a lot more deprecated in production, but that's why it's so much cheaper to experiment in Dev. We're low in the totem pole when it comes to the CLI commands across the backbone of Azure. You get put towards the bottom, but it's still worth it.
It just never takes this long.
Of course not, we're on.
There we go. Destruction complete after a minute. So now we can run our same CLI command to actually show that, hey, look, there's nothing there. Terraform lunch and learn could not be found. So now we'll move on to a little bit, build upon that example. We'll go into example 2 here. And so we're going to now add an Azure App Service Plan and App Service to this resource group. So same thing here, we configure Terraform, we do it with the same version, same configurations for the Azure provider. So now here's kind of something new with this local variable. So it's very much a variable like code. You just declare that, hey, I want my resource group name to be Terraform Lunch and Learn. And then as we go down here to creating our resource group again, we can use that local variables declaration in multiple spots. We don't have to remember to type Terraform Lunch and Learn 15 times. So we're going to create the resource group again, and then here's where we're going to create our Azure App Service and App Service Plan. We give it the name, and we're just going to tack on Service Plan, so it's all named kind of similarly. And then here, in this particular spot right here, this is where I'm starting to use that Terraform object variable reference. So this RG is actually a reference to this Azure resource group within Terraform. So we're able to pick off these attributes from these different resources and use them in other spots. And so we could have, reused our local variable and reused the location, but there's some attributes that get created in Azure that we don't necessarily know. And so we can actually take those attributes in Terraform and use them later on. And then Terraform will figure out which order it needs to create the resources in order to pass those attributes to the things that depend on them. We can kind of see that down here with our actual app service resource that we're going to create. So we give it the same name, but then right here is where we're pulling this ID field off of our app service object. So this isn't anything that we declared. It's just going to know that, hey, once I create this app service, it's going to have an ID field, and then I need to provide this other resource with that ID field so they all get linked up properly. Hopefully this one doesn't take. Darn it. I'm going to skip the plan just because it's probably going to take a bit.
The intent, is it like just checking, is essentially just doing a check of your code to make sure it can be successful?
Yeah, so it does that sort of check, and then it like downloads certain things from Terraform to so if we were to update our Azure provider, like if there was a 1.37,
Right.
it would update that code locally, and then
Gotcha.
there's actually a file that it creates. We can kind of see it over here in this .tf state. So this gets created when you do your, this is basically just a JSON file that it creates, and that's what kind of manages the state of your current infrastructure versus what you're trying to do. So then it uses that to determine what I need to create, what do I need to destroy.
Gotcha.
Say, so you can see all the things that's going to be created. So here's this ID field that we're going to use again. So this, it says known after apply. So it's not anything we set, but it's going to know that it's pulling in the correct value to create that app service. Say yes.
I guess if we were to kind of roll something like this into production, would you envision some type of front end to kind of handle? Would it be like some type of a marketplace? Or like someone could come and say, okay, I want an app server, this, that, and then this would be running in the back end? Or are we gonna have to have scripts to kind of run this all?
I mean, I guess me as a developer, I'm thinking of it as just, you know, we'd be creating our scripts for, or creating our configuration for the different things that we need for whatever app that we're building. You know, there's a whole kind of science behind how to manage, you know, an enterprise with, you know, with Terraform or any sort of these things. So I don't feel like I've gotten far enough into it to really give you a good answer for that. But I guess in my mind, and kind of for this project, what I did was just created my, you know, piece of infrastructure and then actually created, you know, build pipeline so that when changes got made to it and checked in, it just kind of flows through. So this one actually ran a lot faster than the first one, which is nice. So you can see it created all three of the things that we were expecting. And since there's three things, I'll just pull up Azure and show you where they got created at. So refresh this. All resources. So Terraform Lunch and Learn App Service, Terraform Lunch and Learn App Service Plan. And then if we pull this up, we can see that the resource group it's under is Terraform Lunch and Learn again. Those are the three things that we wanted to create, which is all good. So now kind of, and I've been mentioning this whole project that I was kind of working on because of this. I think it started from the beginning. So I'll explain a little bit before I show the end-to-end thing that I was talking about. If this would. Well, we're just going to ignore this. Oh, there we go. So the end-to-end architecture. So the whole reason why I, you know, decided to do this whole Terraform thing was, so my friend and I run a World of Warcraft website called classicguildbank.com, and we had an existing production infrastructure that I had created by hand, you know, using the portals and different things. And we needed a test infrastructure to roll out changes and stuff too. And so instead of going through doing all the portals and all that crap again, I decided to try to learn this, and it worked out pretty well. So this is what my end-to-end thing builds. The client is a serverless Angular app. It runs on AWS, and so that means it's not running on a Tomcat server or an IIS server. It's running out of an S3 storage bucket that we configured to run as a static website, since Angular is just one HTML file and 5 JavaScript files. So it runs out of an S3 storage bucket, and then we use an Amazon CloudFront distribution, which is their content delivery network, to pull from that bucket and distribute it to the CDN edge servers. And then we also use their DNS routing to give it a friendly name. So it's going to be test.classicguildbank.com. And then we had already provisioned an SSL certificate for the live site. So we're going to use that to give it HTTPS as well. The server is just the ASP.NET Core Web API. It runs on Azure App Service. And then some of the not tricky, but things we had to consider setting are the database connection strings, since we didn't know what the endpoint of the database was going to be yet, and then the cross-origin resource sharing settings to make it so that the Angular app can talk to the web API. And then finally, the database is just an Azure SQL Server. And then we're actually going to restore a backup of our prod database into the test one so that we can have good data to test with. So now that we talked about all that, I'll actually show you the Terraform file that creates all this stuff. You can already see that this folder is a little bit more complex than the other ones, but we will start off with just our main Terraform file. And so, kind of as Bill alluded to and Reed talked about a little bit, the end goal of all this is to run this in automation. And so, when you run it in a pipeline or something like that, you can't be doing an interactive AZ login, selecting your login and doing all that stuff. The way we get around that is there's a couple ways. And the way that I believe is most recommended by Terraform is using these environment variables that I've kind of made a disclaimer about here. And so those are just the different environment variables that Terraform automatically looks for, and if they're present, it's going to use them to authenticate to the different providers. So I had to set up two. I had to set up the ARM client and all that stuff for Azure, and then here's the two that was needed for AWS. On top of that, you can also specify your own custom environment variables if you want to use them as inputs. So that's what these ones down here are, this TFR, backup key, and backup URI. I'm using those to specify where to grab my database backup from. So you can put as many of those as you want, and then all you have to do is declare them in this variables file to say, hey, I'm expecting a variable db backup key and db backup URI. So now this is where we configure Terraform. And so this is a little bit different as well, since this is running on, in a pipeline. As I alluded to with the TF state file, that can't be locally created, and Terraform can't know what its current state is if that VM keeps getting destroyed each new build. Or if you're operating in a team, pulling down the same Terraform file, your state files are going to be out of sync. So Terraform allows you to store that state in an Azure container. And so every time you initialize, it's going to look and see, hey, I should grab my state from Azure out of this specific bucket and this key, and then it's going to use that state file and update that state file. Moving down, just some local variables that I needed to declare. And then here's where we kind of set up our providers. AWS was a little bit tricky, so I had to do some things like override one of the providers, but that's pretty AWS specific, so I'm not going to get into that a whole lot. And then we set up the Azure one just like we did before. And then here we are utilizing these data tags. So data tags are just like a resource tag, except they're like read-only. So this data tag for the Route 53 zone is I'm saying, hey, there's an AWS resource out there, an AWS Route 53 zone that has the name classicbuildbank.com. Go fetch that information so I can use these attributes off of it later on. So we're doing the same thing with the certificate that we have provisioned as well. So I'm not changing anything with those resources. I just want to get the information that's already out there. And so now we just start configuring the resources as we have before. So there's the resource group. Here's where we're specifying our SQL server, specifying things like login, password, stuff like that. And here's, I'm adding some firewall rules so that Azure can talk to the database, so that Azure apps can talk to the database server, so that different IPs, like my personal computer, can talk to the database server. And then here's the Azure SQL database that we're creating on that server. And this is where we're using that, that variable for the backup URI and backup key to say, hey, create this database using an import of this backup. Scrolling down, this is where we're creating our app service plan. And here's where we create the app service, setting up some settings, connection string. Again, we're pulling off the fully qualified domain name from the database resource that we created right here. And then this is kind of an interesting thing. So Terraform had either a bug or a known issue with this particular Azure resource and setting up the cross-origin resource sharing block. For whatever reason, I couldn't get it to work correctly. So they offer these things called provisioners. So provisioner is kind of like a hook into the Terraform lifecycle. And so I'm actually executing an Azure CLI command as it's creating this resource. And so I'm using the Azure CLI command to set the core settings, and then using the Terraform variables that I have already set up. So that's kind of cool. And so that's the whole server side piece. And then so what Terraform also allows you to do is create these things called modules. So I created a whole module for the whole client side piece. And a module is just like a class or a function in application code where it's meant to be reused. These are our inputs. You can define outputs, and then you kind of wrap it up and hide it away in a separate Terraform file. So you can see this is where our module is declared. So that's kind of where the source code is coming from. And then these are our 3 inputs. So if we look modules, static web, and we look at our Terraform file to create the whole client side thing, we can see we're creating the same very similar resources, except these are all AWS flavored. And I know we're not going to be an AWS shop, so we don't need to spend a whole lot of time on these, but they're there if you want to look at them later. So after all that, let's pull up the actual CLI command, and thankfully it actually worked. So I started this right at the beginning of the talk, and I think it probably took about 30 minutes to create all of that stuff from scratch. So we can actually look at the logs and see what it created. I apologize if this is a little small, but I don't think I can zoom in on this. So you can see all the different things, the Azure SQL Server, CloudFront distribution, firewall rules. You can look through all these logs. Hopefully, if this is all named the same, go to please. So now I'm actually deploying my application code to the infrastructure we just created.
Yeah, I got a question. So all that infrastructure configurations that you showed us, how do you go about like debugging it? I mean, I know obviously you can see the logs like you showed us, but is there any other way than just say do all of it and then you just have to read the logs what had an issue, or can you actually kind of like step by step and like debug if there was an issue, like you misspelled a variable name or something like that?
Yeah, so I mean, the way I did it was I kind of developed it all locally on my machine, and I didn't use those environment variables. I just hard coded all the keys in there just to get something working.
Okay.
And then when I was ready to move it to like a pipeline thing, then I started pulling out hard coded keys and started, doing the things that needed to be done in a pipeline and not necessarily like an interactive way. So I just made sure that I would create it, I would destroy it, change a few things, create it, destroy it, change a few things, and just I kind of did that as my workflow. And then once I got it all set up to be able to run in a pipeline, then that's kind of when I just shifted it all up there.
Gotcha.
So if you go back and look at how we manage those keys, those environment variables in a automation sort of way. Edit. So we can see that this process is 2 tasks. We're going to install Terraform on the pipeline, and then we're going to run a bash script. You can see we're doing it in a init, and then we're doing an apply. And these arguments are just to make it non-interactive. So the way we set the environment variables here is that there's this convenient environment variables section. So this is where I set all the ones that it requires. And the cool thing with Azure DevOps is it allows you to use these variables in like a linked variable set. So we go to these variable groups. So I've linked all of my access keys from an Azure Key Vault storage, and then Azure DevOps pulls them in as build time variables. So when I'm working in this pipeline, I don't even necessarily have to know what my keys are. They can be managed by an entirely different person. As long as this key name is the same, so that's the key name in the Azure Key Storage, Azure DevOps is going to pull it in and assign it to the correct environment variable. And me as a developer, I don't need to care if the access token is expired or if they're revoking them and reissuing them for whatever reason. So that's how we get everything set up in a automation scenario. And then if I look, and let's see if works the way it should. We can at least look in the Amazon portal. Bucket. See it created test.massivecodebang.com. This is what
Oh, yeah, it's not the best UI. You don't
Yeah.
see so much.
I hate the AWS UI. Go to CloudFront, I'll just pull the so you can see it deployed my code to that CloudFront thing that I just created, which is test.classicalbank.com. The part that failed in this pipeline was I think it was refreshing the CloudFront caches. So I don't know if the actual URL would work, but we can try it. Oh, it looks like it does. So same thing. That's all I had. If you guys want the slides or any of these examples, I put them up on my GitHub, so you can go there and grab them. Any other questions?
So conceptually, for we was to put this into practice, even for our dev environments, right? So some of the feedback that that made when they gave us their demo. So their demo was all, they essentially built this, but it was all on-prem. They created their own cloud bubble, but it was on-prem. But conceptually, the ideas are the same.
Yeah.
And I asked them, what was their biggest regret? And they said they were allowing the infrastructure to live too long.
Mm.
So when they were working with developers, they got a lot of pushback and said, we need it for 60 or 90 days. So they started at 90 days. And the problem was they just had bubbles and bubbles and bubbles of infrastructure sitting out there. And the last time I talked to them, they were trying to rope it down to 15 days. And that was just on-prem. And the biggest problem they had was obviously resource on the back end and physical hardware. My question for us would be to challenge ourselves, what would be, what would be a mindset that you want this to live for? Because being that we're using public cloud, there's a conceptual cost for every hour.
Yeah.
Right? And that even means over the weekends,
Yeah.
right? So either having it short-lived or being able to park it off hours, even at night, on the weekend. Because I mean, even though it is in the dev Azure, it is cheaper than product, but it's depending on what we're talking about, it could be anywhere between a quarter an hour to $5.
Yeah.
Right?
Yeah,
So,
I guess I would look at it as a developer, like if if I'm not actively developing in it, I don't need it up and running. If it takes, if I can set it to, spin up in 20 minutes, I can do that at the beginning of the morning, go grab a cup of coffee, and by the time I'm ready to start working, it'll be up and running. Then I can either tear it down myself at the end of the day, or it can run some automated process to run for a day or two or 3 or a week.
Yeah, and there's some scripts to run it, because we've looked into this as we're starting to get our feet into Azure. Granted, it's a different code set, but even within Azure, I can put it on a scheduler to say, hey, spin up these servers at 2 a.m., spin them down at 6 p.m.
Yeah.
Kind of thing, right?
So I mean, even with like here in our pipelines, we could set up.
Because really the idea is it should be quick iterative use,
Yeah.
right? And I know when we looked at doing something like this, even on Crown, our biggest hangup that we had on the infrastructure side, because we looked at this about 2 years ago,
Mhm.
and our biggest problem was getting test data, right?
Yeah.
Having some automated generation of test data to build, to hook into each
Mhm.
quote unquote bubble,
Yeah.
right?
Yeah, I was about to say, like, one of the things that we did at Domino's was basically make it so that we spun up environments as needed. And that was actually really convenient. Like, we're talking database data within the database,
Yep.
all of the artifacts, everything, just as an automation test would kick off, that'd be the first thing, build the environment, and then run off of that. That way you had complete control over what the data was going to be, the state of the application, and all that sort of stuff. And that was super helpful.
Yeah, I can definitely see that. And then I guess I wonder, how did you handle certain applications that, like, there's always going to be anchors, right? Like OnBase, for example. Would that just be within a shared resource for all the bubbles to be able to access that if they need to proof out a test bed, right? And same thing with domain controllers, right? Those are always anchors,
Yeah.
right?
As far as I know, we did have, I guess we had one anchor, which was the old legacy monolithic
Sure.
application that all of our microservices connected to. And at that point, it was just, that thing was just always running.
Yeah. Which I guess we would treat Cornerstone as like that as well, right?
Just kind of like an always on, but if you've got microservices and different database tables and different things that, smaller databases and different things that you can interact with, there's no reason why you can't just spin it up as needed.
Right.
So, kind of like you were saying, you can set this on a schedule to spin it up at 7:30 and then have another step to say tear it down at 6 p.m. or something like that, so that every single day it would go through the same thing.
And that's not just turning it off, that's actually
That's
deleting,
destroying.
Yep.
It's no longer in Azure. You're no longer being billed for it.
Yep.
It
Force you
doesn't.
to check in every day.
So what kind of servers would not be a candidate for this? It sounds like there's some mainstay servers that we can't bring down ever, right? They're gonna sit there and prod forever, but this is more for like development environments, test environments, development environments, just spin up, spin down, as needed.
I don't think it goes beyond being able to bring things up and down. It's more just to keep things consistent across the board. So, consistently applying the same updates, consistently having the same software installed on all your servers, and just knowing that your dev environment is actually matching what's going out in prod, because your prod environment has been configured the exact same way.
Well, right, so that's partially configuration management, right?
Yeah.
In terms of provisioning, if you have things already in prod the way you want them, but they're working, can you reverse engineer and create scripts from prod?
So yeah, you can do that with Terraform. It's kind of a tedious process. As far as the other tools, I don't know what the reverse engineering process would be. So with Terraform, they actually have an import command. So you can describe a resource the way you want it to do, like Terraform import, and then it'll go out, kind of query that thing, and then pull back the information and put it in its state file so that it knows about it.
So I guess it could get to the point of, just if we was to pick an application and just run it through all the environments, when it goes to prod, I would use that same script,
Yeah,
right? And then make sure it's checked in. And then the next update or the next, maybe even a patch cycle, I would potentially rerun that, like destroy it and recreate it off of that script, right? Like those servers, they don't have any meaning to me anymore. I don't care about Lansing at health. I know I can recreate it with this script. And I know it's on version 1.125.
yeah.
And it's been vetted all the way through the whole server of itself. Its whole life has been re-vetted all the way through. And maybe it's a matter of disjoining it from the domain and rejoining it to the domain with this new script. Right?
Or think about too, like, if you're setting up a new development environment, like you pull down a copy of, prod or dev or whatever scripts you want, then you could actually run that in something like a Docker container and then, have your own dev environment running on your machine in a container.
It's funny you said that because that's the next step, right?
Yeah.
Containers is like, that's what wraps all of this. And then you can talk about bleeding and then having multiple copies up and only exposing certain, like, I think containers is really the game changer. Like, this is a great tool to verify and vet consistency.
Mm-hmm.
And then, containers is really the real wrapper of where you see the benefits of being able to do multiple releases a day and bleeding out one bucket while the other one's being hydrated, right? So.
Yeah, even from a dev standpoint, they showed us at Dev Intersection the ability you can actually run Visual Studio Code within a container. So you can have your own container, your own dev environment that there's an image out there. So instead of spending 2 weeks setting up your laptop, you go pull a Docker image, run your Docker container, and then run your development environment in that Docker container and do your development in that.
Any performance hit with that at all, or is it?
I mean, you can specify the resources that it uses, so.
Awesome, sir.
Anything else?
I got a question.
Sure.
It's just my lack of understanding, but like, so in your scenario, you spun up like a SQL server, right? And actually have like a database instance. Now, like in some of our development environments, we have like one SQL server with many databases. So like ours and Centric would all share the same SQL server with just different databases. So when you're talking about spinning stuff up and spinning stuff down, if you're saying you want a new SQL server, do you not have to specify like an actual server that it's running on? So like would our resources in our database be spun up and spun down in the same manner that Centric's would be? Because you wouldn't want like the interference, right, between.
Well, does your database, does it require, like, does Centric put things in that's required by yours,
No,
or you just
just
share it in
assume
the
that
database?
Yours is yours for
Okay.
your application.
So then at that point, you don't need to specify like an endpoint necessarily, like, so in this, so if we go up, so like in this connection string, for your particular app for Portal, you could create a whole new database that, let's say we have some backups sitting out there. You could spin up your own new database, and then you wouldn't even need to know what IP or what, domain name it gets qualified with, because you can just pull that attribute in after it gets created, and then your app will automatically point to that new one. You don't need to know that there's a database out there. You can just say, I want a database, and then I want to point my app service to that database. And then you can just use these, these attributes that are available to build your configuration for that.
Yeah, and SQL is very complex in Azure. Right now I know at least 4 different levels. So you could have like a full-blown VM, like a full-blown SQL server like we are traditionally today. You can do SQL as a service, or you could even do SQL instance as a service. So each instance is its own resource group. And then that would kind of be like your own little private sliver that you can work out of. And really the idea is to get to this micro consumption. That way we're not buying a whole server, we're just buying like a database space, right? And it really starts to compartmentalize all that out. Because today it's like, oh, it's MSC, or it's, DW SQL. There's 100 databases in that. But essentially, every database could be its own SQL call, per se.
Is that cheaper than to have like a virtualized actual SQL server with all those databases?
That's debatable. There's a lot of study that would have to do around that, right? But the biggest thing is if I do a SQL VM, I still have to manage the VM. I have to patch it, I have to keep it up, keep it healthy, do my SQL patches. If I do as an instance, I'm just consuming that.
Yeah, so
Microsoft handles that for me.
So this is what I believe Bill's talking about. So the SQL server that we just created is SQL as a service. So you can come in here and you can specify like, they use this thing called DTUs, which I don't exactly know what they are or how they bill you for them, but it's basically like,
It's all about queries.
yeah, it's some function of like how much you're actually using. I can't see if I can find billing.
The whole game here in the cloud now is, I know this is all for DevOps and keeping your environments consistent, but another angle, is it to minimize your footprint in the cloud because of the billing, way it bills? Or is that a major focus when you're going to the cloud?
Oh, billing is by far, I mean, it's gonna be a good part of someone's job to maintain hands around billing. The good thing is, like, I don't want you guys to have to sweat that. So right now, today, we're actively working to build guardrails around that. So like, for example, even as you're scripting this out, well, we don't need a $5,000 an hour server, right? We're not trying to do quantum physics. So I'm gonna put in a policy that says, no, you can't build that server, right? I'm gonna give you the bubble or the box to play in, but I'm gonna protect us from those mistakes, right? So I don't want you guys to have to worry about that stuff when it comes to building, like, so no matter what anybody tells you, like, going to the cloud is not cheaper by any means. It's just not. It's just about convenience and about doing this kind of stuff. And the change that Microsoft does, which is good and bad, the journey that we've had, even on the 0365 side, is us staying up to date on all these changes. Even in the GUI, right? Like, oh, this button used to be here, well, they've moved it now to over here. They're just constantly making changes.
I mean, conceptually to me, it feels like going from a full all-service cable service, right? Like Xfinity to all this Hulu and Netflix and HBO, Max.
Yeah, but you want Disney Plus.
Right? Everything everybody wanted, right? They wanted a la carte, now they got it,
Yeah.
but now it's gonna end up it might end up costing more.
It will cost more and I probably shouldn't say this as an infrastructure guy. IT, like, if you've been in IT long enough, you know that it's a circle. So I would not be surprised in our career we don't see us coming back to this. I'm not saying in 5 years, but everything is just repetitive, and we're seeing it. So when I first started in IT, it was all in the data center. You open boxes and put RAM and hard drive and switches and all that good stuff. I'm not saying we'll go back to that, but we went from distributed to centralized to now cloud. Some of the Fortune 500s, they're coming back in, right? They're coming back to their own data center for their own reasoning.
They create their own cloud.
To create their own cloud, that's right. They're creating their own private clouds.
So still provisioning things, they're still using IAC.
Yeah.
Right, but they're just, it's a little bit more their control, their speed, they can control that journey a little bit more. I don't know, it's interesting, I'm glad I'm in this part of my career to see this journey, but I would say in our career, we'll see it come back. Something will happen of either a break of trust or a disruption of service, something major. The good thing to know that I tell myself and the team is when we're in Azure and there's a bubble or a bump, it's everybody. It's not just Greenstone. It's Ford. It's, Chase. It's all these big players. Yeah, we can open a ticket, but Greenstone is nobody compared to Ford, Chrysler, Coca-Cola.
The US government.
Yeah, well, be careful, because the US government is on their own Azure bubble.
Oh,
So
did
we
they?
looked at
Okay.
that. Yeah.
Okay.
So DOD and government is on a .gov Azure, we were gonna go to it because we get federal pricing, because even though we're not federal, we're still within that protection. The biggest problem is they're about 18 months behind the public Azure space.
Oh, okay.
So they're really controlled, right? Like, they're really slow, they're not adapt to change. And that just felt like a backward step for us. But yeah, good point. There's bigger fish that would be in trouble than us. And I'll be honest, we see it, right? So last year, perfect example, for 3 days, MFA was broke. For 3 whole days, multi-factor authentication was busted. Microsoft's answer was, you need to have a backdoor account, a break glass account in case that happens. We're like, are you kidding us? That goes against everything you've taught us and everything. And now there's this massive tech write-up about it of, you have that one backdoor account, but all the bells and whistles go off if that account gets used. But, I mean, that happens, right? I mean, we're gonna get disrupted, and that's what I say, it's gonna take one of those massive events. I know AWS had one last year, I can't remember it off the top of my head, but, I mean, Netflix was affected by it. Like, so you just kind of have to accept that as you go. Which is hard for us as infrastructure people because we take pride in speed, performance, uptime, providing those resources to you guys, right? I mean, I don't want to say us against them, but you know, we provide that service to you as developers. Now it's just we're gonna be in this together.
Well, what's interesting, I was just talking to Reed this morning about a NAS unit. He's been asking around about NAS units, you know, you have your own private cloud.
Yep.
So you've already seen the shift in the consumer market where, you know, they've been pushing everyone up to the cloud and everyone's kind of pushing back a little bit, saying, oh, security, I don't want my stuff up there in the cloud, and they don't know a lot about it, and they're skeptical of it. And now we've come from that point, which, you know, 10 years ago, to now, here's your own private cloud. It's still not, you know, it's expensive to set one up for yourself, but then, you know, they're pushing people that way.
Yep.
Or, you know, so I'm not surprised, I guess, is what I'm saying, that we're starting to see that shift.
One of the things that a lot of people at home don't think about, what if your house goes up on fire?
I know, we were just talking about that too.
I mean,
So yeah, you gotta have some sort of offsite storage at some point, right?
Yeah,
Makes
and
sense.
the biggest way
So,
I've justified us going to the cloud, and I don't want to get too nerdy with you guys, but is my cost for DR and backup, now I just put all that cost towards my Azure, because that's covered once I'm in Azure, right? As long as I design it correctly. So we're kind of breaking even at the end of the day of what I spend for DR and backup. Now it's just, I'm consuming it all in the cloud, and those services are just modulars that I have, like a la carte, right? And so perfect example is, so we're in the East region today, but I think we might be moving. But so it's geo-redundant. So the East region, and then it's the West region is its sister region. And if you set it up correctly, it can be hot. We can have 2 hot data centers. I don't think we're at that level of where we are today. Some may make justifications for portal, but if it takes 30 minutes to spin it up, I think that's fine, right? But there's just a lot more of that is just given to me as a service when I'm in Azure, versus today I have to go find a provider, vet out that vendor, vet out that tool, train up the team to how to use it, another vendor for support, you know, and then it turns into finger pointing. At this point, it's just all Azure stuff. I know, like, I'm talking like I drank the Kool-Aid, but it makes, you get a lot more efficiency.
His mouth is right here.
Yeah, it's.
I was like to say, as long as it's great Kool-Aid.
Oh, man. But no, I mean, it's a cool time, and I think your experiment is really neat to see go through. I just think, you know, as we find time, like, what is something we could vet that out today with something we have, right? Like, what can we do to keep learning and keep that momentum going? Because this is our future, right? For sure. Everybody in this room, if you're here because you want to be part of it. And to be part of this mission to go forward, it's going to take a lot. And I think there's a lot that we still have to vet out as a team. Like, are we saying we expect all developers to take on this infrastructure stuff? Or do I need to have some site reliability engineers that are some dev and some infrastructure that could set that stuff up for you? Because it's its own skill set, right? I mean, not every developer understands infrastructure and the networking behind it all and how to do all that, nor do we want you guys to spend those cycles. We want you spending it on improving apps, right? But I think that'll flush itself out as we keep having conversations, and talking about this. And then as a management team, we push it upstairs and keep talking about, hey, here's the trend we're seeing, here's what we need to do. But this is absolutely our future, especially with Dynamics 365 coming, right? Hopefully we get some direction maybe this weekend where that stands, but it's coming, right? I mean, heck, we talk about moving TFS even, so.
I think you were gonna say something, but maybe at the back end, I noticed that the pipelines have a lot of similarities to Octopus. Is Octopus something that can be used with Azure pipelines, or is it easy to export and import the rules?
I think there's plugins that you can do. I mean, Azure Pipelines is Microsoft's version of Octopus. It's their deployment tool set. It's also, now that they own GitHub, Azure Pipelines and GitHub Actions are basically the same thing. So yeah, Octopus is another version of that. You know, there's other continuous deployment tools out there. I believe you could hook into their build pipelines and put like an Octopus step or do something like we currently do with TFS, where we actually create the Octopack and then push it off to the Octopus server, and then you could then use Octopus from there on out.
I'm just thinking about all the stuff we're doing in Octopus,
Mhm.
and at some point in time, maybe we move to pipelines rather.
I mean, I haven't looked a whole lot at how Octopus like structures their releases, but one thing that I think we were talking about yesterday in the meeting, as far as like managing even your build pipelines as code, you can come in here. I mean, you can declare these as YAML files, so you can come in here and there's a setting you have to turn on. It's not live yet, but you can kind of view the YAML that's behind this build pipeline. So at the end of the day, you know, if you don't want to use the GUI and you want to check in your build pipeline as a YAML file and then manage it through source code like you would anything else, you know, Azure Pipelines does that. I don't know about Octopus. Maybe there's a way to do it with that, but I haven't tried it, so.
Most things can be exported as PowerShell, so there's a couple of things that can't, but
Octopus.
Octopus, yeah. So instead of YAML, they just say, here's a PowerShell script. If you want to do this on your own, just here's a PowerShell script. There's some things that can't. There's some steps that are, I think, proprietary to them. Like,
PowerShell's too, especially for Azure stuff.
You can like a one-stop shop with having the board.
Yeah, I like Azure Pipelines. I'm a fan of them.
That was actually what I used at my last job. So most of the stuff that I'm trying to do in Octopus, I'm having to relearn because I did in Python.
I just kind of feel like at some point we're gonna have to be like, well, let's try to do what we did in Octopus and move it over to Azure. Not saying we do it immediately, but
Yeah, well, I had
it's definitely something we have to.
I mean, I feel like
I have
it's
a feeling, oh, I'm sorry.
Oh, no, go
I
ahead.
was just gonna say, I have a feeling that like once we actually make the transition to Azure DevOps, we're going to be transitioning a lot of our tools over here. Because like there are a ton of different things here that are available, up to and including like boards. Instead of doing lean kit, maybe transitioning over to boards instead. And everything is highly integrated, so it just makes sense to transition over to Azure DevOps when you've got two tools that do the same thing and one looks better with what you're doing.
And it's all in one integral.
Yeah.
Yeah.
And then plus, like, I mean, what's beyond, like, Linkit, there's a cost to it. Well, this is just part of it, right? Like,
Do we know what the mindset of people like Matt, Steve, and stuff towards this kind of, you know, we just went to Linkit and those type of
There was
things.
something they disliked about some version of TFS is like work cards or whatever. I forgot what it was called.
they weren't that customizable as they are now.
So I'm not sure if that's fixed and that it looks like it is, but I haven't looked into all the features.
I haven't looked at how customizable. They made them a lot more customizable. But
work
they're still
items.
made for development, and Linkit is used across the whole
Yeah.
everybody, the whole corporate, everybody uses them. So like learning and development has a huge board of just here's all of our stuff, and is
As a developer, I absolutely hate Kit. I can't stand it. I hate the tiny little window that pops up that people try to cram too much detail into. There's no inline screenshots. All that stuff drives me absolutely crazy.
And I just created my own automation board at this point, and it's way more complicated than it needs to be. It's just a blank board. So it's just like, oh my gosh.
So I think it's, as we have these kinds of lunch and learns or even these tribal events, right, as a group, like, I think that's important. It's that feedback that we can provide to help shape this journey, because it is still in its infant state, right? Everybody in this room, I don't want to say it again, but you're all here to have a voice and to make shape that journey. So just continue experimenting and give feedback and talk through all this with us as we do this, because you don't get an opportunity to do this very often.
Yeah.
Once in our careers. So your input is very valuable.
The original question, I broke you away from what you were trying to show us with something about cost allocation.
Oh, with the SQL Server.
You were trying to.
Yeah, so I just I believe the thing that we created, and Bill had mentioned this was SQL as a service, and so this is kind of how you configure the resources that it uses and how much it costs. So you have these things called DTUs, and it's based on query and consumption. These are like data transfer units or something. You can read about what a DTU is on your own. But you can scale it up to, if we scale it up to, 3,000 DTUs, it's going to cost us $4,500 a month. So, if you really need that, those teraflops of data processing, then you can do something like that. But for this little test website, we don't need more than 5 DTUs.
No, but we take it out of your bonus.
So.
Thanks, Amy.
Yeah.
Yeah,